Hello, this is Michael Guarino, and I'm going to give you a quick overview of the Plural platform and its fleet management capabilities. First, what you're seeing right here is just a quick overview of all the clusters that have been injected into Plural. It's worth mentioning what that means for per cluster to be um, under management for Plural's fleet manager. Basically, what happens is on each cluster, there's going to be an agent installed in the cluster. We have available Helm charts and Terraform installers to make this doable in a very easy and simple way. And from a networking perspective, the only constraint that's needed for management is egress networking from the managed cluster to your hub cluster, which will also be self-hosted somewhere within your infrastructure for maximum security. Once that agent is installed, there's a lot of value we can actually provide right out of the gate. The first big source of value is starting to give you a lot of the information that you would need to be able to successfully upgrade that cluster without potentially causing any availability risk on the part of applications housed within that cluster. The way we do this is we detect a lot of the common CNCF add-ons that you will extend your cluster with. Kubernetes is ultimately something close to an operating system kernel within the distributed systems world, and it needs to be complemented with a lot of systems like ingress controllers or external DNS for DNS registry or cert manager for installing certificates. We maintain a full compatibility table that will let you know whether your current version of any of these components is compatible with Kubernetes at the various versions that you might be targeting. And also, we also maintain tables to ensure that they're compatible with each other mutually. A lot of these controllers will actually use each other's APIs in a lot of Baroque ways that your team is not necessarily going to understand. In addition to just this simple view, which you can see all these controllers are safe to go to Kubernetes version 1.28, you can go in and see the full compatibility table in case you needed to jump a few minor versions to get yourself up to date, release URLs and READMEs for all of these add-ons. Alongside that, you're going to be basically deploying a lot of raw Kubernetes YAML into those clusters alongside these third-party open source tools. That those Kubernetes APIs you're using can also break in future versions of Kubernetes. It's worth noting that could end up being a very large sprawling amount, especially if you heavily leverage APIs like the ingress resource or others on the networking space that can oftentimes be fairly complicated, and the Kubernetes community has shown a tendency to breaking. This kind cluster we see down here is actually one cluster that we have a few deprecated APIs in. If we click on this button, you can see we're using the pod security policy that was going to be permanently removed in version 1.25, which is not yet a problem because this cluster is on version 1.23. That said, if you wanted to get ahead of the problem, we do give you a get URL to see where in your source control that resource is emanating from. And that's ultimately because all the services within Plural are sourced from Get or similar source control providers. And we can use that to back reference where it was ultimately hosted. You can see the deprecation emanated from this specific service, the PSP service, on this kind cluster. Now, going on in depth a little bit, we don't just provide you very simple tools to manage the upgrade lifecycle. We also give you really great single pane of glass visibility into all of your clusters. So if you go to this tab, you can see all of the services that have been deployed fleet-wide. That's a total count of about 61 services. And we can dive into the services and see the actual details of the running components that were actually deployed. This specific service as well is running on a K3s cluster on my laptop, being communicated with via management cluster in AWS on EKS. This sort of highlights some of the network flexibility. There's obviously no way in which AWS can make an outbound network call into my laptop in New York City. But the agent-based architecture allows for that flexibility. The way it does that is the agent actually does establish a WebSocket outbound to the management hub cluster. And that WebSocket is bidirectional. We know how to route Kubernetes API requests onto that bidirectional channel as a means of communication. So going in, we can see the details of this Kubernetes deployment off of the Kubernetes API on that K3s cluster. We can go to the pod, look at the logs, see all the information that you might need as an operator to be able to understand what's going on in that cluster, even though there should be no logistical way in which a web UI ordinarily would be able to get that information. Other tools that are really very useful for getting visibility into your Kubernetes fleet is our integrated Kubernetes dashboard. This is completely multi-cluster compatible. You can see it has support for all the three EKS, K3s, and other clusters that we have in the fleet. And it'll allow you to be able to see the full details of any Kubernetes object within your fleet, including their raw view and the capability to edit. This is ultimately all RBAC enabled and leverages Kubernetes impersonation to use the email and groups attached to the user as it logs into Plural to perform that RBAC authorization request. By default, users will have no permission unless you configure RBAC rules for them. It's also worth noting that any component in the system as well has its own RBAC settings. So you can see the cluster has the ability to add read and write permissions, similarly with the services, and so on and so forth. This allows you to ensure appropriate security posture within our UI. You can grant only read or write permissions to specific teams for specific clusters or for specific services, ensuring that they don't be able to see things in which they should not be able to have access to. Now I'm just going to go quickly through what it means to deploy a service. Before I go through here, I will also caveat that this is all doable via Kubernetes CRDs or Terraform as well. There's a lot of infrastructure as code solutions to give you a best practice setup of all these resources. We're going to demo it in the UI because it's a lot easier to see and follow along. So the simple process is we'll get a get URL. It will likely need authorization. Then you'll deploy a service, and I will just do that on our kind cluster because that will also highlight some of the network flexibility that the agent architecture gives. Then we're going to go into master and deploy a simple guestbook service. It does not need secrets, and then we can find it right here. And you can see it was deployed effectively instantly. We can then jump in and look at the logs of that service. And you can see that those logs did start just a few seconds ago. So everything went A-OK. And then we'll also delete that service just to clean up after ourselves. Now, going into some of the more advanced capabilities, one of those is what we call global services. So this is basically solving the problem of you need some service duplicated throughout your fleet. There is a common level of, you could think of as runtime level concerns that you want to have done fleet-wide, like establishing RBAC rules. You can see this RBAC global service has been created on every element of the fleet. There are other things like setting up OPA gatekeeper for policy enforcement. In this case, we've only set those up on the EKS clusters in the fleet, primarily because a lot of the local Kubernetes clusters running on my laptop simply can't handle the load that gatekeeper will impose upon them. But other things like setting up the Kubernetes stack agent to provide monitoring and log aggregation is another great example of something that you would likely want to do with a global service. Global services can be targeted by Kubernetes distribution or by tag. This wizard will give you an example of the CRD that would be needed to create one. So let's just create a global service for the prod tier clusters and only an EKS distribution. And the exact global service CRD would look like something like this. In this case, pointing to an example service that you've already created to make it global. You can also do this via the UI, which I'll show an example of right here. You can take a service, make it global, give the same details in the wizard, and the system will duplicate it as need be across the entire fleet. The other really powerful workflow we can provide is the capability to provide full release pipelines. In this case, it's a pipeline from dev to prod with a manual approval and an integration test needed to confirm the promotion. We can kick that off just by creating a dummy revision in the base service that will trigger the pipeline to run. And you can see now it's actually asking for the approval and the job to run. We can go ahead and approve it and then wait for the job to complete. That will oftentimes take a little bit of time to both trigger and then ultimately do what it needs to do. You can see now it is in running state. Once the system realizes that it's completed, it will move into a completed state. But we can go into the job and actually see the details of what was going on. In this case, it's just running hello world. You can see the pod that was actually run to complete the job, and other details of the running integration tests from there. And you can see it did actually complete now, and it deployed itself to prod. Another really powerful workflow you can do with pipelines is the same promotion process, but triggering each revision of the service via PR creation and approval instead of via API call. This is mainly meant to allow you to automate the Git operations you would need in a fully GitOps enabled environment to do the promotions. In a lot of other worlds, you would have to do this entirely manually via manual processes, manual PR flows. And we know that if you have that human in the loop, you have the chance of misconfiguration or wasted resources. PR automation is sort of geared towards making that a much simpler process. And an example of how that would end up working, we can actually trigger it as well via Git. So I'll go into my Git repository real quick and then find the file that would need to be edited. It's just this PR context that's bound to the PR automation pipeline. And I'm going to set the context to drop it to 6.5.2 as an example for this demo. And then we're going to push. It will take a little bit of time for the system to realize that that Git has changed. There's a 2-minute poll interval. Once that poll interval is done, it will actually pick up the new PR automation resource and bind that context to the pipeline. I will go ahead and do a little bit of work to potentially accelerate that process. So you can see the PR was created just now. I'm going to go ahead and approve it. It was created with my specific user, so I won't be able to actually approve it, but I can merge it. And delete that branch. Once the system realizes that that was done, and I can accelerate that a little bit here, it will require an approval. And then the pipeline will create a second PR to ultimately update the prod service, which the UI will detect in a second. And you can see it did see that PR was merged. And eventually the pod info service will also be updated to the appropriate value. Which we can accelerate right now. And you can see the prod service is now at 6.5.2, as we expected. And cool. So that goes through a lot of the capabilities of Plural from a fleet management perspective. There are some other things that users might be worth investigating. For instance, our backup and restore capabilities built on top of open source Valero. We have other capabilities that are coming down the pipe as well that is worth mentioning. Managed namespaces for managing multi-tenant cluster setups as alongside Terraform CD to complement our Kubernetes CD capabilities, where you oftentimes need a lot of physical infrastructure to properly deploy things on Kubernetes, and an integrated experience is a much more powerful product as a result, and much more. So hopefully this is a really useful and compelling demo for you guys, and feel free to let us know if you're interested in learning further.